Have you ever pondered the age of our universe? It's a question that might sound simple, yet it's anything but. Determining the age of the universe is like trying to unravel the most intricate of puzzles. A puzzle with pieces scattered across the vast expanse of cosmic space and time. Why does this matter, you ask? Well, understanding the age of the universe is not just about satisfying our cosmic curiosity. It's about uncovering the history of time itself, tracing the evolution of galaxies, stars, and maybe even life as we know it. It's about piecing together the cosmic jigsaw puzzle that can help us comprehend our place in this grand cosmic narrative. So how does one even begin to calculate the age of something as immense and complex as the universe? What tools do scientists use? And what clues from the cosmos do they follow? So how do scientists figure out the age of the universe? Let's dive into it. Most scientists believe our universe began with the Big Bang. Now, what exactly is the Big Bang theory, you may ask? Think of it as the ultimate origin story. Around 13.8 billion years ago, our universe was a hot, dense point, nearly infinitely small. It was nothing like the vast expanse we know today. Then, in a fraction of a second, it started expanding rapidly in a hot explosion, hence the name Big Bang. This wasn't an explosion in space, as space didn't exist before the Big Bang. Instead, it was an explosion of space itself. Everything that exists, all the galaxies, stars, planets, and even space and time, came into existence after this event. But here's the fascinating part. This expansion didn't just stop. Our universe has been growing ever since, like a loaf of bread rising in the oven. This idea of an ever-expanding universe is a key part of the Big Bang theory. Now, if the universe is expanding, it means that it was smaller in the past. If we could somehow rewind this expansion, like a movie in reverse, we would end up back at the Big Bang. By figuring out how fast the universe is expanding, we can estimate how long it took for the universe to expand from that initial point to its current size. In other words, we can estimate the age of the universe. But estimating the rate of expansion isn't as straightforward as it might seem. After all, we can't exactly put a ruler next to a galaxy and watch it move. Instead, scientists use a variety of clever techniques to measure this expansion, each with its own set of challenges and limitations. Which brings us to the question, but how do we measure this expansion? We use a concept called redshift, but we'll delve into that in the next scene. Stay tuned. Redshift is a key tool in estimating the age of the universe. Imagine you're standing by the side of the road and a fire truck races past, sirens blaring. As the truck moves away from you, the sound of the siren changes. It becomes lower in pitch. This is known as the Doppler effect, and it doesn't just apply to sound. It also applies to light. In the realm of the cosmos, this effect is known as redshift. When a galaxy is moving away from us, the light it emits appears to shift towards the red end of the spectrum. It's like the universe's way of telling us, hey, that galaxy over there is moving away from us. Now, you may be thinking, okay, but how does this help us determine the age of the universe? Well, the faster a galaxy is moving away from us, the more its light is redshifted. So if we can measure how much the light from a galaxy is redshifted, we can estimate its velocity, how fast it's moving away from us. But wait, there's more. The degree of redshift also allows us to estimate the distance of a galaxy. This is because the universe is expanding uniformly. The farther away a galaxy is, the faster it's moving away from us. So we've got velocity and we've got distance. What's left? Time, of course. Here's where Hubble's law comes in, named after the astronomer Edwin Hubble. This law states that the velocity of a galaxy is directly proportional to its distance from us. So, by knowing the velocity and the distance of a galaxy, we can estimate how long it's been moving away from us. In other words, we can estimate how long the universe has been expanding. And voila, we get a rough estimate of the age of the universe. So, by measuring redshift, we can estimate how long the universe has been expanding. But there's another method too, scene script. Another method for estimating the age of the universe involves cosmic microwave background radiation. Imagine the universe as a grand concert hall where the Big Bang was the first note of the symphony of existence. The cosmic microwave background radiation, or CMB for short, is what we might call the echo of the first note. This radiation is a relic from the early universe, a snapshot of the universe when it was just about 380,000 years old. At this point, the universe cooled enough for atoms to form, allowing light to travel freely for the first time. This ancient light is the CMB, and it fills every corner of the cosmos, permeating the universe like a faint whisper of its fiery birth. So, how does this help us estimate the universe's age? Well, the CMB is not perfectly smooth. It has tiny temperature variations, minute hot and cold spots. These patterns in the radiation were created by sound waves traveling through the early universe, and they provide a wealth of information about the cosmos's infancy. By studying the patterns in the CMB, scientists can determine the geometry of the universe. And it turns out, our universe is flat. This is crucial information because it allows us to calculate the rate at which the universe is expanding. This rate, known as the Hubble constant, is a vital piece of the cosmic age puzzle. Knowing the Hubble constant and the geometry of the universe, scientists can reverse engineer the universe's expansion. It's like rewinding a film of an exploding firework to the moment it was launched. By doing this, they can estimate the age of the universe. So, the CMB is an invaluable tool, a cosmic time machine that takes us back to the universe's early days. It's one of the most significant pieces of evidence we have for the Big Bang theory, and a vital tool for understanding our cosmic origins. So, combining these methods, what age do scientists estimate for the universe? After using these methods, scientists estimate the universe to be around 13.8 billion years old. It's a number that's hard to fathom, isn't it? An age so vast that it stretches our understanding of time itself. This number, however, is an estimate. It's based on the information we have gathered so far, and it comes with a margin of error. The age of the universe is calculated by measuring the distances and velocities of distant galaxies, observing the oldest known star clusters, and studying the cosmic microwave background radiation. These methods have allowed us to piece together a cosmic timeline, and they suggest that the universe is approximately 13.8 billion years old. But, like all scientific findings, this number is subject to change. New discoveries, new methods of observation, and new interpretations of existing data can all refine our understanding of the universe's age. For instance, recent research suggests that the universe might be slightly younger than we currently believe. Some scientists argue that it could be closer to 12.6 billion years old. However, even with this potential adjustment, the universe is still incredibly old. To put it into perspective, the Earth is around 4.5 billion years old, making the universe roughly 3 times older than our planet. The quest to determine the universe's age is a testament to human curiosity and ingenuity. It's a question that has intrigued scientists for centuries, and it's one that will likely continue to inspire scientific exploration for many years to come. By studying the universe, we're not just learning about distant galaxies and cosmic phenomena. We're also learning about ourselves, our origins, and our place in the cosmos. Every discovery brings us one step closer to understanding the grand story of the universe. A story that began around 13.8 billion years ago. So, while we may not have an exact number, we have a pretty good idea of how old our universe is. It's all thanks to the ingenuity and curiosity of scientists.